In our lesson today, we're going to find percent increase and percent decrease using algebra. In the last lesson, we learned how to calculate a percent increase or a percent decrease. This always took two calculations, one to find the amount of change and one to find the percent of change. All right, in this lesson, we're going to look at how we can do all of this with just one calculation. In order to help us with that, though, we're going to first review how we factor an expression. Okay, we did factoring all the way back when we looked at algebra. And remember that when you factor an expression, you're going to rewrite it as the product of a GCF and another expression. Okay, in our first example, I want to factor completely 4 plus 4x. Now, there were two different methods that we studied. One, we could either list the factors of each term and then do division, or we can use something that I like to call the ladder method. Okay, and in fact, that's what I'm going to do. I'm going to use the ladder method. So I'm going to put this kind of upside down division box around each of my terms. Okay, and then I'm going to look at each term and I'm going to see what's something that would divide into both of those terms. Well, I see a 4 and a 4x here. I know that 4 would divide evenly into both of those. Okay, so if I divide each of these by 4, 4 divided by 4 is 1, plus 4x divided by 4 is going to be 1x. And then I put the factor box around each of those terms and I repeat the process. All right, what would divide into 1 and 1x? Well, the only thing that would divide into those is the number 1. And when you divide, nothing's going to change. So I know I've gone as far as I can go. Now, my GCF, I take the two terms that are on the outside here and I multiply those together. 4 times 1 is 4. And then I multiply it by what was left over at the bottom of the ladder, which was 1 plus 1x. Okay, so 4 plus 4x is equal to the product 4 times 1 plus 1x. So there's our expression in factored form. In question B, again, we're going to repeat the process. We're going to factor completely. I'm going to put my factor box around both terms. And 125 plus 125n, 125 would divide into both of those evenly. So let's divide each by 125. 125 divided by itself is 1. 125n divided by 125 is 1n. Okay, and this is similar to what we did over here. The only thing that's going to divide into 1 plus 1n is 1, which again gives us 1 plus 1n. So our GCF, 125 times 1 is 125, times at the bottom of the ladder, 1 plus 1n. And there's your answer in factored form. Okay, factor 30 minus 3y completely. So we'll start by putting the factor box around each term. Okay, I look at each term and I see that 30 would divide evenly into both of those. 30 divided by 30 is 1. Negative 30y divided by 30 is negative 1y. So we have 1 minus 1y. And we repeat the process. But the only thing that divides evenly into each of these terms, again, is a 1. So we're left with 1 minus 1y. For the GCF, 30 times 1 is 30, times at the bottom of the ladder, 1 minus 1y. So now that we understand how to factor, let's look at a percent increase example to see if our algebra can help us to better understand our process. Example 2, Jeff currently earns $280 per week at his mother's flower shop. Next month, Jeff will be getting a 5% raise. All right, question A asks, by how much will Jeff's weekly salary increase by? Show your work. Okay, well, we can start out by writing our percent change equation, which says that change is equal to a percent times the original amount. And we know that Jeff is getting a 5% raise. When we use our equation, we change that into a decimal. 5% is equal to 500. So we'll record our rate as 500ths. And we know Jeff's original salary is $280. So 500ths times 280. That'll tell us C, how much his salary is going to change by, specifically how much it's going to increase by. All right, so to get the value of C, all you have to do is multiply 500ths times 280. And when you do that multiplication, C should be equal to 14. Okay, so we can say that Jeff's salary will increase by $14 each week. Okay, Jeff's salary will increase $14 each week. Question B asks, what will Jeff's new salary be after the amount from Part A is added in? Well, that's pretty easy for us to figure out. He had an original salary of $280 each week. Now his salary is going to increase by $14 each week. We add those together, we get $294. So Jeff's new salary will be $294 each week. Okay. Well, question C asks us to let n be a single number that we could multiply Jeff's $280 salary by to find his new salary. Set up an equation and solve it for n. Okay, so originally we saw up here that Jeff had a salary of $280 per week. After his raise, we know it's going to be $294. I want to know, what number could I multiply 280 by in order to get 294? Okay, well, that number that I could multiply 280 by, I'm going to call n. So I'm going to take Jeff's old salary of $280, and I'm going to multiply it by some value n, and that's going to equal Jeff's new salary, which is $294. Okay, I have to solve this equation for n. Right now, n is being multiplied by 280. To isolate the variable, well, all you're going to have to do is divide each side by 280. On the left, 280n divided by 280 is going to leave us with 1n. And on the right, if you do 294 divided by 280, that's going to leave you with 1 and 5/100ths. 1 and 5/100ths. So if I did 280 and multiplied it by 1 and 5/100ths, that would give me the new salary of $294. Question D. Write Jeff's new salary as the sum of his current salary and the decimal rate times his current salary. Then factor this expression and compare it to Part C. All right. Well, take Jeff's new salary. We're going to write his new salary as the sum of his current salary. So his current salary, remember, was $280. Sum means to add. So I'm going to add the decimal rate times his current salary. All right. The decimal rate times his current salary. Well, remember, he was getting a 5% raise, and 5% as a decimal was 5/100ths times his current salary, which was $280. Okay, so his current salary plus 5% times his current salary equals his new salary of $294. I'm going to factor this expression, and then I'm going to compare it to what I got up here in Part C. So I'm going to put my factor box around each of these terms. Okay, and I have a 280 here plus 5/100ths times 280. Notice that 280 is a part of each term, so I could divide each part of those by 280. 280 divided by 280 is 1 plus 5/100ths times 280 divided by 280. Well, that's just going to leave you with the 5/100ths. 5/100ths. Okay, and now this can't factor any further, so 280 times 1 plus 5/100ths would be our answer in factored form. Okay, compare this to our answer, which was in Part C. Compare this expression to what we got here in Part C. Well, look at what's inside of the parentheses. All right, inside of the parentheses is 1 plus 5/100ths. 1 plus 5/100ths is equal to 1 and 5/100ths. So if I did 280 times 1 and 5/100ths, that's going to equal the new salary, which was $294, which again, we saw right here. 280 times n, which is 1 and 5/100ths, equals the new salary. Okay, so if I wanted to show that Jeff was getting a 5% increase, all I had to do was take his current salary and multiply that by 1 and 500ths. He's going to get 100% of his current salary plus an extra 5%, which is why this is 1 and 500ths times 280 to get his new salary of $294. In example E, we are told that Jeff's sister Marcia makes $440 per week from the flower shop. If she also gets a 5% raise, use what you found in part C and D to calculate her new weekly salary. Okay, so let's do a quick review of what we found in our last example. I'll bring in a copy of the notes here. Okay, we said here in question C that we could easily just take 280, the old salary, and multiply by some number n to equal the new salary. And we calculated that that number would be 1 and 500ths. And then we just proved that down here as well. If we wanted to show that we were going to get a 5% increase, all you have to do is take 280 and multiply it by 1 plus the decimal equivalent of 5%, which was 500ths. 1 plus 500ths is 1 and 500ths. So the old salary times 1 and 500ths, because that's the 5% increase, equals the new salary. Okay, so that's what we're going to do here with Marcia's salary. She currently makes $440, and she's getting a 5% raise. So to calculate what her new salary would be, all you need to do is multiply that by 1 and 500ths. Okay, 1 plus 5%, which is 500ths, is 1 and 500ths. And all we need to do is calculate what that would be. So let's punch that into our calculator. 440 times 1 and 500ths. And that gives you 462. 462. Marcia's new salary is $462 per week. Okay. Well, verify, letter F, verify that Marcia's new salary is a 5% increase over the original $440 salary. Show your work. Okay, well, in order to help us, we'll use our percent change equation. Change is a percentage of the original amount. Okay, how much did Marcia's salary change? Well, that's easy to figure out. All you have to do is 462 minus 440, and we can see that her salary changed by $22. Okay, we also know that the original salary for Marcia was $440. Let's see what R, the rate, is going to be. Okay, we have to isolate R. Right now it's being multiplied by 440, so we'll divide each side by 440. And on the right, 440R divided by 440 is R. If we do 22 divided by 440, notice it gives us the decimal of 500ths. 500ths in decimal form is the same as 5%. Okay, so this right here shows that the $22 raise to get to $462 is a 5% raise. So once again, if you want to show that you're getting a 5% raise, take the old salary and multiply it by 1 plus the decimal equivalent of 5%, which is 500ths. 1 and 500ths times 440 gives you that brand new salary. Marcia's new salary was $462 per week. In example number 3, we're going to look at another percent increase problem to see if we can understand the process of how we can figure out the new value in just one step. Okay, a liquid starts at a temperature of 75 degrees Fahrenheit and increases its temperature by 32% as it heats up. Letter A, find its new temperature by finding 32% of 75 and then adding. Okay, so this would be the old way of doing it. We'll do that with our percent change equation. Change is equal to a percentage of the original quantity. All right, and we know that it's going to be increasing by 32% in decimal form. That's going to be 3200ths. The original temperature was 75 degrees. And C is going to represent how much the temperature changes. All right, so to get the value of C, all we have to do is multiply 32 hundredths by 75. And when we do that, C should be equal to 24. Okay, so that's how much the temperature is changing. That's how much it's increasing. Now to find the new temperature, we take the old temperature of 75, add on how much it's increasing, which was 24, and that gives us an answer of 99. The new temperature is 99 degrees Fahrenheit. Okay. Now, how could we do this in just one step? Find a single number that you could multiply 75 by to get the new temperature. Okay. So 75 times some number is going to equal 99. Okay. Well, let's let n equal the number we multiply 75 by. 75 times some number n is going to be equal to 99. We have to figure out the value of n by isolating the variable. Right now, n is being multiplied by 75, so we'll divide each side by 75. On the left, 75n divided by 75 is our 1n. And on the right, 99 divided by 75 gives us 1 and 32 hundredths. Okay? And hopefully you realize that this makes sense. Okay? Just like we said before, if we're having a percent increase, all you have to do is multiply the original value by 1 plus the decimal equivalent of the percentage. In this case, since it was a 32% increase, I'm going to multiply my original temperature by 1 plus the decimal 32 hundredths, which is 1 and 32 hundredths, and that'll give me my new value right here. Okay, 1 and 32 hundredths is the same as 1 plus 32 hundredths, 1 plus 32%. Since I'm increasing by 32%, I add that to 1. That number times the original will give you the new temperature. Example number 4. State a number you could multiply by to increase a quantity by each of the following percentages. Okay, so remember, to do a percent increase, all right, if we want to increase a quantity by a certain percentage, we're going to take the decimal equivalent of the percentage and add it to 1, and then that number times the original quantity would give the new quantity. Okay, so let's check out example A, 14%. In decimal form, that's equal to 14 hundredths. So I would have to do 1 plus 14 hundredths, and that's equal to 1 and 14 hundredths. This number right here, if I multiply that by the original quantity, all right, the new answer is going to be a 14% increase over the original quantity. What if it was a 3% increase? Well, 3% is equal to the decimal 3 hundredths. Add that to 1 plus 3 hundredths. Okay, so to get a 3% increase, take the original quantity and multiply it by 1 and 3 hundredths. What if it was an 87% increase? 87% is equal to 87 hundredths. Add that to 1 plus 87 hundredths. So you would have to multiply by 1 and 87 hundredths to find an 87% increase over the original quantity. Okay, what about if it was a 4 and 25 hundredth percent increase? All right, well, again, change this into a decimal. The decimal moves to the left once, twice. So we would get 0 and 0.425, 425 ten thousandths. Now we add that number to 1 plus 0 and 425 ten thousandths. And that would give us 1 and 425 ten thousandths. If you take the original quantity and multiply it by this number, that's going to show a 4 and 2500% increase over the original quantity. So we've just seen examples where if we have a percent increase, all we have to do to figure out the new value is add the decimal equivalent to 1, and that will give us the number that we need to multiply the original quantity by to get the new value. When we look at a percent decrease, a similar pattern occurs. Example 5, a container originally holds 375 gallons of water. After draining for 10 minutes, its volume has decreased by 4%. Letter A, find the new volume of water by finding 4% of 375 and subtracting. Okay, we'll use our percent change equation. Change is equal to a percent of the original quantity. And they tell us that it's going to be decreasing by 4%. 4% in decimal form is 4 hundredths. The original amount of water was 375 gallons. And we're going to calculate, see how much the water is going to decrease by, how much the change is going to be. If you do 4 hundredths times 375, that gives you an answer of 15. Okay, so 4% of 375 is 15. This is how many gallons are going to be decreasing. So we take how many we started with, 375 gallons, and subtract off how much it's changing, 15 gallons, and that leaves you with 360 gallons. The new volume is 360 gallons. After 10 minutes, there will be 360 gallons of water in the container. All right, question B. Let n be a single number that you could multiply 375 by to find the new volume. Set up and solve an equation for n. Okay, so kind of like what we did in the past, all right? I could take my original number 375 and multiply by some number in order to get the new value of 360. Okay, that number I'm going to multiply 375 by, I'm going to call n. 375 times n is going to equal 360, the new volume. Okay, let's isolate n by dividing each side by 375. On the left, 375n divided by 375 is 1n. And if you did 360 divided by 375, that would give you the decimal of 96 hundredths. 96 hundredths. Okay, well, question C asks, why does this number from part B make sense? What's the connection between getting 96 hundredths and the fact that we were having a 4% decrease in the volume of water? Okay, well, if we think about it in terms of percentages, all right, the full container, 375 gallons, that was 100% of the container. And we said that it was decreasing by 4%. So if we subtract off 4% from 100%, that leaves you with 96%. And 96 hundredths is the decimal equivalent of 96%. Okay? So if I did 375 times 96 hundredths, 96%, that gives me the new volume. Okay? So if it's a percent decrease problem, all you need to do is take 1 and subtract off the decimal equivalent, in this case 4 hundredths, and that would give you the number that you would need to multiply by, 96 hundredths, in order to get the new value. Okay, so 1 minus 4 hundredths, 100% minus 4% is 96% or 96 hundredths, and then 375 times 96 hundredths equals the new 360 gallon volume. Okay, so for a percent increase, add the decimal equivalent of the percent to 1. If it's a percent decrease, subtract the decimal equivalent of the percent from 1. In example 6, we're going to state a number that you could multiply by to decrease a quantity by each of the given percentages. All right, so in letter A, if I wanted to show an 8% decrease, okay, well, I'm going to take the decimal equivalent of 8%, which is 8 hundredths, and I'm going to have to subtract that from 1. 1 minus 8 hundredths, all right, and if you do that math, 1 minus 8 hundredths is equal to 92 hundredths. So you would take your original quantity and multiply by 92 hundredths in order to figure out what an 8% decrease would be. Okay, and that makes sense. 100% minus 8% would be 92%. which is 92 hundredths. Letter B, what if it was a 27.5% decrease? Well, again, change your percentage into a decimal. 27.5% is equal to 275 thousandths. And then you subtract that from 1. 1 minus 275 thousandths. And that's going to be equal to the decimal of 725 thousandths. So if you multiply your original quantity by 725 thousandths, that's going to show a 27.5% decrease. If it's a 56% decrease, the decimal equivalent of 56% is 56 hundredths. 1 minus 56 hundredths would give you 44 hundredths. Okay, so you multiply your original quantity by 44 hundredths. That'll show you a 56% decrease. And finally, what if it was just a 0.5% decrease? Well, again, we'll change that number into a decimal, move the decimal point back once, twice to the left, and you will get 5 thousandths. Okay, and now 1 minus 5 thousandths would give you the decimal 995 thousandths. So if you multiply your original quantity by 995 thousandths, that'll show a 0.5% decrease. 100% minus 0.5% is 99.5%.